So, hello everyone. This is Taibiao Zhao. Today I'm going to share a paper, Robust Log-Based Anomaly Detection on Unstable Log Data. So it's a paper about anomaly detection. It contains 4 sections: background, model, experiments, and conclusion. For the background, why we do the system logs anomaly detections? Anomaly detection, which aims at uncovering abnormal system behavior in a timely manner, plays an important role in incident management of large-scale systems, and is usually used for protecting the system from hacking or attacking something. Another question: what is log? Log messages are usually semi-structured text strings. It looks like in this way, shows in the figure, which are used to record events or states of interest in every single computer systems. So as we can see in the figure, it is 1, 2, 3, 14 log events. It is a log message sequence. So this sequence contains 14 log events. That is the log sequence. So as we said in the last slides, the raw log message is semi-structured. So that is not convenient for our training. So what do we have to do at the first step is to make this raw log message to be structured data. So there is the method, the parsing. So the raw log message looks like in this fashion, and after parsing, it looks like a very clearly fashion, and it looks like some templates. These stars represent some parameters. So why these logs is unstable? As we all know, our computer systems update and some other systems also update. So when their system updates, this log statements changes. And here is a figure showed about the evolution of log events across versions about some systems. And we can see from these figures.
One question, sorry, Taibiao, okay. Sorry to interrupt you. So the system update here, what do you mean? It's like Windows, every time we update the system, is that a kind of update, or what kind of update?
Yeah, like we use this when our laptop is Windows 11, and right? 1 year ago it is Windows 10, so it is kind of update.
Okay, so it is this kind of update. Okay, got it. Thank you.
Okay.
Okay.
Yeah, as system update, the original the log system changes, and the unchanged log events become less and less because there is more and more new type of log events come out. So it is the log instability.
So what is this like a data from? It's from what kind of system here?
You mean this figure?
Yeah. The evolution of log events across versions. What is the versions? What is the?
Oh, it's called Service X in Microsoft.
Okay. It's somehow like a subsystem in Windows, or it's a cloud system, or what kind of system it is?
I'm not sure.
Okay.
Yeah. So it is. Here is an example of like the log update. The original is creating and opening new channel factory, and after the system update, it comes out 2 new words in these log events for byting ID. So these 2 log events are 2 different log events because these stars represent some parameters, and there are 2 different log event templates. So for the log anomaly detections, the existing method are shown in these flows: log collections, and then do the log parsing to make this semi-structured log to be the structured data set, and then do the feature extractions, and last do the anomaly detections. Here is a very important things in the third steps, the feature extractions. And we can see there is something called event count matrix. And this matrix contains 4 rows, and every row in this matrix is a vector. It represents a log sequence. It means the vector, oh, sorry. The first row of this matrix is vector. It is 10, its dimension is 10, which means in the first log sequence, it contains only 10 different kind of log events. Yeah, so then this feature extractions to count the number of the 10 different kind of log templates. And then here's the number 1, 0, 2, 0, 1, 0. So it means this sequence contains only the first kind of log events, and the 0, the second kind of the log events, and the 2, the third kind of log events. So in this way, this matrix, its dimension is fixed, which means when it comes out a new type of log events, this matrix dimension should be 11. But because this matrix, its dimension is fixed, is 10, not 11. So the dimension is incompatible with the unstable log events. And also because it contains only the number, it only counts the number of the log events in a sequence. So it ignores the context information. So it is the flaws of this existing method. Here is the model in this paper, the log robust. There is very highlight sections in this model, the semantic vectorization. To overcome the instability problem of real-world log data, this semantic vectorization is proposed. It's the most important improvement for unstable log data. In this way, the unstable log can transform into the same dimension vectors. So this matrix is still the dimension is still fixed, but when there's some new logs come out, it is okay. It doesn't matter. I will explain it in the following slides. So here is the 2 important things in the vectorization. First is word vectorization. The fast text algorithm can sufficiently capture the intrinsic relationship among words in natural language and map each word to a D-dimension vector. Here the D is 300. It means in a log event, it contains many words, but every single word can be transformed into 300 dimension vectors. And here is another things, TF-IDF. If a word in a log event appears frequently, and they use the term frequency, is the number of the word about the total number of the word in a log sequence. It means if the log event contains 5 words, the total is 5. And if it contains only 1 word of this block, the number of word is 1. Oh, let me do some examples. Yeah, here is the semantic vectorization. The log robust extracts the semantic information of log events and transform each log event into a fixed dimension vectors. Here is the example. I can explain it more clearly. The third log event is receiving block and something, and after pre-processing, it contains 4 words, and every single word become to, after the word vectorization, become to a fixed dimension vector. And after the TF-IDF, it has every single word has a respectively weight. Then they combine these 4 vectors become to a new log event. It's a vector, not than a sequence. Here is another thing about this log robust is the attention-based classification. Here is the bidirectional LSTM to capture sufficient information of input log sequence in both directions and reduce the impact of log data noise. This mechanism means larger the alpha is, the more the model pay attention to this log events. Okay, here is the experiments. Before the experiments, there are 3 questions. How effective is the proposed log robust approach on unstable log data? And the second question, how effective is the attention mechanism in the proposed log robust approach? And third question, how effective is the proposed log robust approach on stable log data? In these experiments, it contains 3 different data sets. Yeah, the third one is the most important, is the synthetic data sets. It contains unstable log events dataset and unstable log sequence dataset. This new testing 1 and the new testing 2. The testing 1 is the unstable event. It means the single log event is unstable. The new testing 2 is unstable sequence. It means the sequence is unstable. Here is the fashion of synthetic log events. The original log events looks like this, and they add new words to the log event or remove words from the log event to produce the unstable log event. And for the synthetic log sequence, the original log sequence is event 1, 2, 3, 4, 5, and they delete events or shuffle the events or duplicate the event in the sequence to create the synthetic log events. So here is the implementation and environment, and the evaluation metrics is precision, recall, and F1 score. For the first question, experiments on unstable log data. The table 2 shows the experiment result on synthetic HDFS dataset of unstable log events. As we can see, the log robust performs much better than other approaches. And with the ejection ratios increases, the other methods declined in some degrees. Their precision and the recall reference score all declines as the ratio increases, but the log robust performs still very good. The injection ratio means the ratio of unstable log data. And here is the experiment's result on synthetic of unstable log sequence of the new testing 2 set. It is the unstable log sequence. As we can see, the log robust performs best on the all injection ratios. And here is the experiments on the Microsoft's industrial log datasets. The log robust performs much better than other approaches, especially on F1 score. So for the second questions, the experiments on attention mechanism. This figure shows the F1 score of the attention model on synthetic datasets of unstable log sequence. So as the injection ratios increases, the advantages of attention-based by LSTM becomes more explicit. For the third patterns, experiments on the stable log data. The log robust can work effectively not only on unstable, but also on stable ones. Here is the conclusion. In this work, the semantic vectorization and the attention mechanism are great ideas, especially the first one, which can handle the unstable log data. In the future, the computer system update more and more frequently. The logs become more and more unstable. The previous method based on log count vector, whose dimension cannot be changed as it is constrained by the number of known log events. So that's all. Thank you. Do you guys have any questions? I don't know whether you understand this ideas.